Imagine standing on the surface of Mars, a world of dust, silence, and thin air. There are no thunderstorms, no rolling clouds like on Earth. And yet, something invisible is happening. Tiny sparks are dancing in the Martian air, not the kind that lights up the sky, but something smaller, quieter, and far more mysterious. What if Mars, a planet we once thought was mostly dead, is actually crackling with hidden energy? For decades, scientists suspected that electrical activity might exist on Mars, but there was never direct proof. Until now, a robotic explorer far from Earth has captured something no one has ever recorded before. Not lightning as we know it, but something scientists are calling mini lightning. What does this mean? Could it change how we explore Mars, or even how we survive there one day? Let's uncover the story behind this invisible phenomenon and why it might be more important than it first appears. Deep on the dusty plains of Mars, a robotic explorer has been quietly working, collecting data day and night. This robot is equipped with advanced instruments, including microphones and cameras designed to study the Martian environment in ways never done before. Over time, it gathered hours of recordings, sounds of wind, grains of dust hitting metal, and something else. Something unexpected. Scientists analyzed nearly 28 hours of audio and visual data. At first, the recordings seemed ordinary, just wind and dust storms. But hidden within the noise were faint signals, tiny bursts that didn't match anything typical. These signals turned out to be evidence of electrical activity in the Martian atmosphere. But this wasn't lightning like on Earth. There were no bright flashes lighting up the sky. Instead, these were tiny discharges, similar to static electricity. Imagine rubbing a balloon on your hair and feeling that small shock. That's closer to what's happening on Mars. Researchers describe these events as mini lightning. They are extremely small and weak compared to Earth's lightning, but they are still significant. These sparks occur when charged particles suddenly release energy, creating tiny arcs of electricity in the air. Over the course of 2 years, the robot detected 55 of these mini lightning events. Most of them occurred during dust storms and swirling dust devils, which are common on Mars. These storms play a key role in generating electrical charges. Mars has a very dusty atmosphere. When wind lifts fine particles into the air, they collide with each other. This friction causes them to exchange electrons, building up static electricity. The process is similar to what happens in deserts on Earth, but on Mars, it may be more intense due to the dry conditions. Eventually, the charge becomes strong enough to discharge. When that happens, a tiny spark forms, releasing energy between particles or through the air. These sparks are the mini lightning events that scientists have finally detected. Interestingly, these discharges were recorded within about 2 meters of the robot's microphone. This means the sparks were happening very close to the machine itself. The sounds of these discharges could even be heard over the powerful Martian winds. This discovery confirms something scientists have long suspected, that Mars is not electrically inactive. Even without thunderstorms, the planet has its own form of atmospheric electricity. Electrical activity has been observed on other planets as well. including gas giants like Jupiter and Saturn. However, Mars presents a unique case. Its thin atmosphere and dusty surface create a completely different environment for electrical phenomena. These mini lightning events may seem harmless, but they could have important consequences. Electrical discharges can interfere with electronic systems, potentially damaging equipment used in future missions. For engineers, this discovery is crucial. Understanding how electricity behaves on Mars will help them design better spacecraft, robots, and even spacesuits. Future explorers will need protection from these invisible forces. There's also a scientific mystery tied to these sparks. Electrical activity can trigger chemical reactions in the atmosphere. On Earth, lightning plays a role in forming certain molecules. Could similar processes be happening on Mars? If so, these tiny sparks might be influencing the chemistry of the Martian atmosphere in ways we don't fully understand yet. They could even contribute to processes that scientists are still trying to explain. What makes this discovery so fascinating is how subtle it is. These are not dramatic flashes of lightning, but quiet, almost invisible events. Yet they reveal that Mars is more dynamic than we once believed. As scientists continued to study these electrical signals, they began to notice patterns. The mini lightning events were not random. They appeared more frequently during specific environmental conditions, especially when wind speeds increased and dust density reached higher levels. This suggests that Mars has its own subtle rhythm of electrical activity, almost like a hidden cycle driven by its atmosphere. To understand this better, researchers compared these findings with similar phenomena on Earth. In some of the driest deserts on our planet, static electricity can build up during sandstorms. Tiny sparks can form when grains of sand collide. But on Mars, the atmosphere is much thinner, and the particles are finer, allowing charges to accumulate differently, potentially making the electrical behavior more unpredictable. Another interesting detail is the role of dust devils. These swirling columns of dust, which can tower high into the Martian sky, act like natural generators. As they spin, they lift and separate particles, increasing the chances of charge buildup. Inside these rotating columns, countless collisions may be happening every second, silently creating bursts of electrical energy. What makes this even more intriguing is that these electrical processes might extend beyond what the robot can detect. The instruments only capture activity within a limited range. It is possible that much larger or more frequent discharges are occurring elsewhere across the planet, completely unnoticed for now. Scientists are now considering how these electrical events could influence future exploration missions. Dust is already one of the biggest challenges on Mars. It covers solar panels, reduces visibility, and interferes with mechanical systems. If that dust also carries electrical charges, it could stick more easily to surfaces, making it even harder to manage. This raises an important question for human exploration. Imagine astronauts walking on Mars, surrounded by fine electrically charged dust. Their suits, equipment, and habitats would all need to be designed to handle not just physical wear, but also continuous exposure to static electricity. Even small discharges over time could create unexpected risks. There is also the possibility that these electrical sparks could affect communication systems. Signals transmitted between equipment might experience interference if the surrounding environment is electrically active. Understanding these effects early will be critical for building reliable systems on Mars. Beyond engineering challenges, there is a deeper scientific curiosity. Electricity has the power to drive chemical transformations. Some scientists speculate that in the distant past, similar processes could have played a role in shaping the Martian surface or atmosphere. While there is no direct evidence yet, the idea opens up new avenues of research. In the end, what started as faint, almost unnoticeable signals has grown into a significant discovery. These tiny sparks are revealing a side of Mars that was hidden in plain sight. They remind us that even the quietest worlds can hold dynamic and complex processes, waiting patiently for us to uncover them. Mars continues to surprise us. Beneath its calm and dusty surface lies a hidden world of activity, where tiny sparks flicker in the thin air. These mini lightning events may be small, but their implications are enormous. They remind us that even in the most unexpected places, nature finds ways to express energy and complexity. As we prepare for future missions, and possibly even human exploration, understanding these subtle forces could make all the difference. So the next time you think of Mars as a silent, lifeless world, remember this. Somewhere on that distant planet, tiny sparks are dancing in the dust, quietly rewriting what we know about our neighboring world.